Hey guys, today we are looking at 4.2 day 1, which is all about adding, subtracting, and multiplying polynomials. So today should be a really easy day for us. Should be a review on everything we've done so far. There shouldn't be anything that's brand new. The only exception to that would be towards the end of box 4. I'll give you some different multiplication, some factoring shortcuts, but again, most of those you already know how to do them. It's just going to be reminding you of how we do them for higher degree polynomials. So box 1, we're just going through and adding polynomials together. So if we're trying to add 3x cubed plus 2x squared minus x minus 7 and x cubed plus 10x squared plus 8, we're going to go ahead and just copy those down here real quick. 2x squared minus x minus 7 plus x cubed minus 10x squared plus 8. We know that anytime we're trying to add two polynomials together, we're going to be adding only like terms. So anything that matches degree and exponent-wise, so base-wise. So we've got these three different sets of like terms. My x cubed terms together, 3 plus 1 is a 4x cubed. My x squared terms, 2 minus 10 would be a negative 8x squared. I don't have anything to combine together with my negative x, so that just stays as it is. And negative 7 plus 8 is a positive 1. So 4x cubed minus 8x squared minus x plus 1 is my final simplification. Now, an alternative way that I never really showed you guys how to do back in Algebra 1, if you think of, if I was going to try and add 125 with 6,281, doesn't matter. If I was going to add those together by hand without using a calculator or anything, there's some of us who might be able to just add our ones places together, add our tens places together, add our hundreds places together, and so on. But most of us, if we're thinking back to how we were taught back in early elementary school, if you're adding 3-digit or 4-digit numbers together, you stack them over top of each other. Right? 6,281 plus 125 gives me 6. This is 10, so I carry my 1. 4, 6, so 6,406. I can actually do that same thing with my polynomials. And this is kind of more similar to like box multiplication rather than just foiling, where you're kind of layering them together, in which case I want to be stacking like terms over top of each other. I call this vertical addition for polynomials. So we've got 9y cubed plus 3y squared minus 2y plus 1. And I'm adding negative 5 y squared plus y minus 4. Because you can see now when I do this, all of my things that are stacked over top of each other are like terms. So 1 minus 4 is a negative 3. Negative 2 plus 1 is a negative y. 3 minus 5 is a negative 2y squared, and I still have that 9y cubed. So it's kind of like actually when we were solving systems by elimination, kind of that idea of it, of adding our terms going down. But that's the general idea there for addition. Now subtraction, we should know, is not any different. What you have to be careful of when it's not described or not given to you in equation notation, we have to be careful of how it's phrased from how it's described from us. Because here, the way it's phrased, we're subtracting 2x cubed plus 6x squared minus x plus 1 from 8x cubed minus 3x squared minus 2x plus 9. So in our brain, we usually think, oh, first minus second. But here, this is the thing we're subtracting from this thing. So actually, when we write this, we're going to be doing 8x squared. Nope, x cubed, sorry. X cubed minus 3x squared minus 2x plus 9 minus 2x cubed plus 6x squared minus x plus 1. And we know for this, when we subtract, we have to switch the sign of the second parenthesis. So my 8x squared minus 8x cubed minus 3x squared minus 2x plus 9 stays the same. And now this becomes negative 2x cubed minus 6x squared plus x minus 1. And then it just becomes an addition problem where I'm just collecting up my like terms. For my x cubes, I've got a total of 6x cubed. For my x squareds, I've got negative 9x squared. For my x's, I've got negative 1x. And then for my constants, I've got positive 8. So 6x cubed minus 9x minus x plus 8. Now I can do the same thing for vertical subtraction. If I'm doing 3x squared plus plus z minus 4 from 2z squared plus 3z, I could do 2z squared plus 3z, and I'm subtracting 3z squared plus z minus 4, which really we know is the same thing as 2z squared plus 3z minus 3z squared minus z plus 4. And hey, look, I'm just going to add up going down. Once I've switched that sign in that whole second parenthesis, I can go ahead and just add up going down. So this is going to be a positive 4 here. 3 minus 1 is a positive 2z. Positive, so it's going to be plus. And then 2 minus 3 is going to be a negative 1z squared. And that's my final answer for that one. Alrighty, moving on to box 3. Box 3. Here we're just multiplying polynomials, so this will be a little more complicated just in terms of the multiplication that's happening, but it's still going to be the same general process. We're either going to be, I can't really call it foiling because here we're not doing a binomial times a binomial, right? A two-term thing by a two-term thing. But it's that same general idea of distribution where I'm taking negative x squared plus 2x plus 4, and we are multiplying x minus 3 in here. So I have to go ahead and distribute my x into all 3 of these terms, and then do the same thing, distribute my negative 3 into all 3 of these terms. So starting with that first one, x times all of those gives me a negative x cubed plus 2x squared plus 4x. And then negative 3 in there gives me a positive 3x squared minus 6x minus 12. And I collect up my like terms. X cubed doesn't have anything to collect with, so negative x cubed. My x squareds give me a 5x squared. My x's gives me a negative 2x. And then my constant of negative 12 stays as it is. So that is my final simplification. That is the product of those two original parentheses. As always, we also have box multiplication for those who prefer that. This is actually where I find box multiplication more useful. Usually I only really use the box when I'm factoring out. I don't usually do it for multiplication. But as you get more terms in here, it becomes more useful for us when we're trying to multiply them together. Because here I have y plus 5 times 3y squared minus 2y plus 2. So I've got a 2-term thing times a 3-term thing. And I can still use box multiplication for that. I'm just going to need to make sure I make my box wider than it is tall. So here I need to have 3 columns, but only 2 rows. Because here I got y plus 5, 3y squared minus 2y, and positive 2. But same process I'm doing for regular box multiplication. I'm going to go ahead and do that here. Y times 3y squared gives me 3y cubed. Y times negative 2y gives me a negative 2y squared. And then 2 times y is 2y. Moving to the bottom row. 3y squared times 5 is a 15y squared. Negative 2y times 5 is a negative 10y. 2 times 5 is positive 10. So then I'm just collecting up my like terms. Now, I'm not going to go ahead and rewrite those at all. I'm going to jump right into collecting my like terms, because the other nice thing about box multiplication, if you notice, these like terms are kind of diagonal from each other. So we can see here that when I collected my like terms, my 3y cubed and my 10 don't have anything else in common. So 3y cubed. But then my y squared, they're kind of diagonal, kitty corner to each other. So 15 and negative 2 gives me a positive 13y squared. And then for my y's, negative 10y and positive 2 gives me a negative 8y. And then I still have that positive 10 there as well. So in total, 3y cubed plus 13y squared minus 8y plus 10. And that's it for regular multiplication. Now, getting over here into box 4, these are some special products. Now, here what I'm going through and doing, I have now a multiplication of 3 different binomials, so 3 different parentheses. And the way that I'll do this is kind of taking it just one piece at a time. There's no real special shortcut for multiplying all 3 of them together at the same time. You're going to pick 2 of them, multiply them together, and then get the answer for that particular product, and then, again, repeat that process with the third one. Now, the rest of these, really, I'm just kind of throwing this out there in case you experience any of these special multiplications. Most of these you've already seen. Other ones we will cover more in depth as we move forward for our different special products and different factoring shortcuts. We've got our sum and difference formula, which is a difference of 2 squares. Our square of a binomial, again, we looked at those for perfect square, completing the square back in chapter 3. These last ones here, cube of a binomial, those are more special ones that we'll look at as we move forward. But just some notes in there for us. We're not going to use any of these for the actual problem in box 4, but just wanted to throw them out there for you. All right, so really what number 7 is asking me to do is to multiply x minus 1 times x plus 4 times x plus 5. And it doesn't matter which ones you start with. You're either going to multiply x minus 1 times x plus 4 and then multiply x plus 5 in there, which is what we're going to do together. Or you could start with x plus 4 times x plus 5, multiply those two together, and then multiply the x minus 1 in there. You could rearrange it any way you wanted to and do x minus 1 times x plus 5 first if you wanted to. It doesn't really matter. You're going to pick 2 of them, and you're going to multiply them together. So here I'm going to go ahead and just FOIL these 2 together. So if I do that, x times x is x squared, x times 4 is 4x, negative 1 times x is negative x, negative 1 times 4 is a negative 4. Still times my x plus 5 out here. I'm going to collect at my like terms, x squared plus 3x minus 4 times x plus 5. And then I'm going to repeat the process over again. I can either do just distribution again. If you wanted to do the box, you could do the box again. That is up to you if you really like that method. Here I'll kind of do an example of a longer one with just the regular multiplication distribution. So here I got to do x times all 3 of those, 5 times all 3 of those. So when I do that, x times x squared is x cubed, x times 3x is 3x squared, and then x times negative 4 is a negative 4x. Moving to distributing my positive 5. 5 times x squared is 5x squared. 5 times 3x is a 15x, and then 5 times negative 4 is negative 20. And then I have to collect up my like terms. I've got squared terms, x to the first terms that I have to collect together. My final answer should be x cubed plus 8x squared plus 11x minus 20. X cubed plus 8x squared plus 11x minus 20. And that's all I got for you guys. That's 4.2 day 1. We're going to do 4.2 day 2 tomorrow. That gets into some more advanced stuff with expanding those binomials, expanding those parentheses that have 2 terms in them. But for at least tonight or today, depending on when you're watching this, your homework is page 170 and 171, 4 through 30, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. And have a fantastic day.